Hey Ryan, I'm going to do my best to kind of walk you through beta oxidation again. The first step or let's start with what beta oxidation is. Beta oxidation is ultimately taking two carbons at a time off of a fatty acid. And the idea of, since we call it oxidation, you can kind of tie that in. So we oxidize glucose. So the idea, again, that we're taking these carbons off and ultimately going to remove them as CO2 in the Krebs cycle. So the first step, just like in glycolysis, is that we have to activate or add energy into the process. That requires 2 ATP. So just like in glycolysis, you're going to subtract 2 at the end of it if we ask for net. Right. Oxidation step, again, is the idea of removing 2 carbons that are ultimately going to form acetyl-CoA. We'll repeat this over and over again. I'll show the next slide. The important thing to note is that each time we take 2 carbons off of our fatty acid, that we are going to gain an NADH and an FADH2. It's also important to note the last cleavage will leave 2 2-carbon molecules. So the rounds of beta oxidation aren't going to be equal to just the number of carbons divided in half, but instead divided in half minus 1. And again, I think this next figure will show you. Right. Each time we cleave off those 2 carbons, that'll give us an acetyl-CoA, and those will enter the TCA cycle to produce all the things just like glucose. So let's take a look at how it takes off. Okay, so if we look here, here's our 12-carbon fatty acid. So I can draw lines here. So ultimately what we're going to do is we're going to chop off carbons just like this. Right? Again, each time we chop off 2 carbons, what we'll call that is a round of oxidation, and what we're left with then is, of course, acetyl-CoA. So here in our first step, we take 10 carbons plus our 2-carbon acetyl-CoA molecule for a total of 12. So this is our first round of oxidation, and we have 1 total acetyl-CoA. We do that again, right? We chop off 2, so now we have 2 molecules of acetyl-CoA and our second round of beta oxidation. Next, we chop off from 8, we chop off these 2, and we go to a 6-carbon molecule, 3 acetyl-CoA now, third round of oxidation. As we continue, again, we chop off these 2 carbons. We're left with a 4 plus our acetyl-CoA molecule. That's our 4th acetyl-CoA and our 4th round of oxidation. Last but not least, when we chop this off, we get our acetyl-CoA, but you'll notice this is already a carbon backbone here, so this just goes right here. We don't need an extra round of beta oxidation in order to do that. Right? So you'll see we'll produce 2 acetyl-CoA in this step, or a total of 6, but our rounds of beta oxidation are only 5. Okay? So my guess is that you probably want me to then go into how to tally up the amount of ATP we have. So let me clear off my annotations there. And we'll do some more annotating. Okay, so again, the important thing to note from this step, again, we have 6 acetyl-CoA molecules and 5 rounds of beta oxidation. So let's do some writing here. So in this situation, again, let's talk about our 6 acetyl-CoAs. I'm going to use shorthand because I'm writing with a laptop mouse, right? So we know that these acetyl-CoA essentially enter the TCA cycle. The TCA cycle is going to give us 3 NADH, and this is painful, and 1 FADH. I might have to go into some super shorthand here in a minute. FADH and 1 ATP. right? So then we can multiply that out and we get, right, 18 NADHs, 6 FADHs, and 6 ATP. Right? We can go through the longhand. I'll just say instead of writing it, but 18 NADHs are ultimately going to pump 10 protons across. We know it takes 4 protons to make one molecule to convert one molecule of ADP to ATP. Therefore, each NADH molecule ultimately makes 2.5 ATP. Right? So we can multiply this by 2.5, which gives us 45. Right. Our FADH, again, we skip complex 1, we pump out 6 protons, and those come across, then that gives us 1.5. So 6 times 1.5 gives us 9. And then ATP is ATP, so that gives us 6. So just from our acetyl-CoA molecules, then, we can say we got 60 ATP. But what about from our rounds of beta oxidation? Again, we get 1 NADH and 1 FADH2 from each round of beta oxidation. As you'll remember, we underwent 5 rounds, so that gives us 5 NADHs. And 5 FADH2s. Again, I apologize, this is terrible. You may just want to rewrite this on your own. Yeah, I'm going to win the award for worst video ever. Right. All right, again, we know that we can multiply 5 times 2.5. Is going to give us 12.5. And then 5 times 1.5 will give us 7.5 for a total of 20 from our 20 ATP from a round of beta oxidation. So we can add those. So 60 and 20 gives us 80 total ATP. And then minus 2 for that activation step ultimately equals 78. So hopefully that helps clear things up. If not, post again.